On this video, I'm gonna show you guys a quick intro into what RNGs are and how to create an RNG via code. Without wasting time, let's get into the topic of the video. So, RNG is actually an acronym and it stands for Random Number Generator. RNG, as its name suggests, adds randomness to our games. RNG has been a big part of many game designs, from early board games to dice rolls to modern video games. On the next videos, we'll create more complex RNGs, but for now, let's create a very basic one. Here's the core idea. When our game begins, our obstacle behavior script will make a decision. Should our obstacles start moving left, or should they start moving right? What will our obstacle's first direction be? So now that we have our introduction out of the way, let's go back to our Unity scene. Alright, we're back to Unity. In the previous video, we created two triggers into our scene and made it so when the game is running, our obstacles will move between the two triggers. So if I have to give a reminder, let's start running the game. And there it is, our obstacles are moving down. They are gonna move towards the trigger and then touch it, and then they will switch directions. And that's a basic loop. Now to start making our first RNG, let's get back into the obstacle behavior script. As its name suggests, we're gonna work with random numbers. So first, what we need to do is create an int variable. So let's do just that by writing private int, and then let's call it first direction. Now we want to give this first direction variable a random number, and we want to do that at the start of the game, not in every frame like the update method does, but at the start of the game, which our start method does. So going to our start methods, we'll write first direction and then Random.Range. Now what this range method do is return an int, or I shouldn't say int, a number between the minimum value and the maximum value. When using random.range with integers, the second number is as exclusive, meaning it won't ever be picked. This means that in our code right here, 0 can be picked, 1 can't be picked, but 2 can't be picked. Now, if you use it with floats, however, both numbers are inclusive. This means that if I were to write something like Random.Range and between 0f and 5f, then this has the possibility of giving me the exact value of 5. Or if we replace it with 2, we can get a value of 2 from this, but not this statement. Now that we have our random value up, what we need to do next is adjust this if statement. Actually, hold on, let's not do that. Instead, I have a different idea. How about first direction? How about this? Our first direction variable should determine what is obstacle going left variable is. For example, if first direction becomes a value of 1, then we can make it so is obstacle going left becomes false, and vice versa. If it becomes 0, then the other variable becomes true, something like that. So let's set that up with a second if statement in the start method. Let's write if first direction equals to 0, then is obstacle going left equals to false. But on the other hand, if first direction equals to 1, then is obstacle going left equals to true. Of course, I need to adjust this statement. Let's remove this too. Now again, to recap, what we are doing here is first assigning a value to our first direction. Our first direction can either take a value of 1 or 0. And then depending on that value, we're assigning a different value to our is obstacle going left. I think our script is done right now, so let's save it and try testing it. And the result is perfect. As you can see, some of our obstacles are started with the left direction and some obstacles started with the right direction. If you're curious about why all the obstacles are not going the same way, the same direction, let me try to explain it the best I can. So, it is true that all of these obstacles share the same behavior script, but this script is run separately with each obstacle. For example, this obstacle may have a first direction value of 0, while this obstacle may have a first direction value of 1. Now that our game works differently, let's try to adjust our obstacles, starting with their position. I want to put our obstacles in the center of our map. So let's do that by selecting all our obstacles and then going to their X value and typing in 0. Then maybe we can make a little more obstacles to make the game a little more challenging. I want to see how that looks like. Let's add 2 more sets of obstacles, pretty much copies. So selecting all of our obstacles, let's copy and paste. And then put this set of obstacles to the right of our first set. Now we will do the same again, but to the left direction of our first set. So selecting our first set of obstacles, let's copy and paste them again, but this time put the new set to the right, to the left. There we go. Now that we have a lot more obstacles, you can see that our hierarchy window is getting a bit messy. So let's try to fix that by categorizing all of our obstacles into one folder. We can do that by going to the top, right-clicking our scene, and then going to game object and then create empty. Now let's call this obstacles. This will be a folder in our hierarchy. And then selecting all of our obstacles, let's put them in the obstacle folder. Closing it. And now it's more neat. But now we have a different problem. As soon as we start the game, our game is gonna break because our obstacles can collide with each other. This is not what we want. So we want to make it so our obstacles don't collide with each other. So, as the first step of our solution, we'll create a new layer. In the previous videos, we already created a new layer, specifically the ground layer. This time we'll create a layer that is focused, we'll create a new layer that is reserved for obstacles. So let's create our layer. First, let's find our obstacle prefab, and then going to the layer, we'll add a new layer. Let's call it obstacle. Why not? Then returning to the prefab, we need to assign this obstacle layer to our prefab. Now let's check if our obstacles have the layer 2. And there it is. you can see that all instances of our prefab now have the obstacle layer. Now, as the second step, we need to make it so these objects that share the same layer don't touch each other, don't collide with each other. To do that, we need to play around with Unity settings. Let's go to the Edit window, go to Project Settings, and then we need to go to Physics Settings. There we will see Layer Collision Matrix. This matrix right here shows us what what layers can collide with what layers. Here's our obstacle layer right here. Our obstacle layer can collide with all of these other layers, but it cannot collide with obstacle layer. So we need to untick this. And I think that's enough. Now let's try going back to our game and try testing it again. And now, there it is. You can see that our obstacles just passed through each other. You can see it again, and now you will see it again. Let's wait a little bit. And there it is. Our obstacles don't collide with each other because they share the same layer. Let's see it again. Now our tutorial is over, but let's try playing the game a little bit to see if I made it too hard or if I need to make some adjustments. So let's try play testing it a little bit. We may need to adjust the camera view because this isn't really working well. I don't think so. Yeah, the camera needs to be changed. But I think I'll do that in the next video. Okay, that's enough for now.